Hi guys, Mr. Stanwood here, and we are going to start our self-paced learning. Um, what I'm going to do is I'm going to make a bunch of videos with some information. You're going to take some notes using the guided notes that I provided into your notebooks, answer some questions, complete some assignments, complete the mastery work, and see if you're ready to move on. So here is the first lesson of the self-paced uh, style. All right, it's from chapter 5. We're doing lesson 1A. It's the reason it's 1A is because lesson 1 is splitting it into a couple parts. This one is all about just rate of change. The objective, I'm going to try to limit each section to one objective. Excuse me. This objective is I just want you to be able to find rate of change from a table. So before we do that, let's just remind you what rate of change is. I'm gonna have to keep moving myself around. Rate of change. I'm not going to read it for you. It's on the screen. You can hit the pause button if you need to, write it down, figure out, rephrase, whatever you want. But it's just a ratio, typically written as a fraction, and it compares the amount of change from the dependent variable over the independent variable. All right. So when we discussed dependent and independent variables previously, it's going to be really important that you can identify which one is independent and which one is dependent. All right. So below here, we have the change in dependent over the change in independent. We make it into a fraction. Sometimes it can be simplified. You always try to want to simplify it if you can. Alrighty? Right. Yeah. So hey, look at that. Look at that guy. When do you actually use or see this rate of change? Occasionally, let's say a population of mice is increasing by 50 mice per week. You know?
Hi, everybody. It's me, Mickey Mouse.
Yeah, he's my buddy. I got him on speed dial. I just got to hang up real quick. Talk to you later, Mickey. All right. That's a weird rate of change, but yeah, it's increasing. It's 40 mice per week. Speed, a car traveling 68 miles per hour, it's changing 68 miles every hour. And then the last one down here, miles per gallon. Often parents siblings will kind of look for cars based on their MPG, miles per gallon. You want a higher number for that because that means you go 27 miles on every 1 gallon of gas. All right. So let's take a look. See here. This table shows the average temperature of a certain city over certain months. We have to do a couple things. Find the rate of change for each time interval, which is pretty much a time period. And then during which time period did the temperature increase the fastest? So let's take a look. See, the first thing we want to do is be able to identify our independent and our dependent variable. Which one depends on the other? Does the month depend on the temperature, or does the temperature depend on the month? Typically, independent variables are time, so figure it out. Which one is which? Answer this question. Great. Month independent, it's a form of time, and the temperature depends on the month. So now all we want to do is figure out what's the change from 1 month to the next. So from 2 to 3, what's that change? It's just going up 1. From 3 to 5, oh man, I'm throwing a curveball at you now. It's 2. 5 to 7, that's just up another 2. And then up from 7 to 8, yeah, that's up 1. All right, so these are not constant, and that's okay. We're not talking about that actually. We're going to talk about constant rate in the next lesson. But for now, I'm just looking at what's happening. You know, each month it jumped up 1, then 2, then 2, then 1. Now I want to find the corresponding dependent increases. From the month 2 to 3, it went up a whopping nothing. It didn't change. The average temperature stayed the exact same. All right. From 56 to 63 degrees from month 3 to 5, it jumped 7. What? It got warm and toasty up in there. From month 5 to 7, it went from 63 to 71. Again, if you're not sure how to do this, we can subtract 71 and 63, and that gives us 8. So that one increased by 8. And our last one, from 71 to 72, that only went up 1. So that's the first step, is identifying what the actual changes are. And now what I want to do is I need to identify what are the constant rates, the rate of change for each interval. So for the first interval, it went up 0 degrees, I'm going to put my dependent change over my independent change, which was 0 over 1. My next change was it increased 7 degrees over a 2-month period. So pretty much that increased 3.5 degrees per month, but 7 halves. The next one was 8 degrees in 2 months, or 4. We're allowed to, like I said earlier, allowed to divide and simplify, so this is 4. And the last one, I went up 1 degree in 1 month. So here are each of my rates of change for this table. Which one increased at the fastest rate? Well, which one of these, fastest meaning biggest? Go ahead. I'll give you time to select the best answer. Is it from 2 to 3, 3 to 5, 5 to 7, or 7 to 8? Great. It is 4. Between months 5 and 7 was the greatest increase. Fastest increase, I should say. All right. One more quick problem. Here's another table. It shows the distance a band marches over time. Is the rate of change in distance respect to time constant? In other words, is there a constant rate? And then what does the rate of change represent? So now not only are we going to find the rate of change, I want to figure out what does it actually mean here. So the first thing we're going to do is identify the rate of change would be the change in distance, which is dependent, over the change in time, which is independent. Time is almost always going to be independent, and maybe we'll talk about when it won't be, but for now, it'll be independent. All right. Now, what we want to do is calculate each change like we did on the previous slide. Obviously, I'm speeding up the process a little bit. We want to do our 520 minus 260, which gives us 260, and then 2 minus 1, which gives us 1. You see them all. I'm subtracting the difference in the distance each time and the distance in the time. And each time, it simplifies down to 260 over 1, 260 over 1, 260 over 1. Oh my gosh. Say what? That's constant. It simplifies to the same thing. It is the same thing. So now, what does this rate of change represent? This represents the distance the band marches in 1 minute. The top number, 260, the unit is distance. The bottom number is 1, the unit is time in minutes. So it is 260 feet in 1 minute. That's what it represents. They're pretty much their unit rate for marching. So if all of these differences have the same rate of change, that means if we were to graph it, it would have the same steepness. The line would increase and form a straight line. All right. I'll say this now, but this is going to be later on down the road. This is actually going to be linear. And this constant rate, I'm giving away some information for the next lesson, is called slope. All right. That is lesson 5.1a. Now, what you can do is you can work on the assignments, complete them, and then the mastery check to see if you are ready to move on.